Dengar ke suara saya ni?
Boleh doktor.
Ya.
Okay. Sebelum saya sambung kepada topik kita, ada soalan ke nak bertanya berkenaan dengan apa yang kita discuss tadi? Okay, kalau you all semua faham, saya proceed kepada kita punya topik kita pada malam ni. Okay, so jadi kita akan buat kepada flood routing. Okay, so kita akan pergi kepada flood. Okay, kepada flood routing. So this is the topic. Sebelum kita pergi, before we go on the calculation, on the design, on the how are we going to determine in terms of attenuation, in terms of lagging of time, in terms of hydrograph before and after of constructing the dam ataupun any flood mitigation structure that you would like to propose. So kita akan tengok. So we have to understand how the flood routing, what is the meaning of the flood routing, and apakah equation yang akan diguna pakai, fundamental, basic equation yang akan diguna pakai, and then apakah jenis-jenis flood routing yang akan diguna pakai di dalam kerja buat flood mitigation structure, flood mitigation measures. Okay, jadi basically before we go further, so basically on the fundamental of the basic equation, jadi kita kena tahu yang saya telah explain. So basically you have the hydrograph. Okay, so this is the hydrograph. Basically kita panggil dia sebagai existing condition. Okay, so this is the hydrograph with the existing condition. Okay, so jadi basically what we do have here, so we have the Q peak. So this is your Q and this is your time. Okay, so basically this is dia punya Q peak 1, which is saya panggil dia sebagai existing condition. Okay, so jadi bila kita buat, when we have this Q peak, so you come out with the one catchment area. So at the end of the catchment area, you have the main outlet. So this is the main outlet where you measure at the end what is the discharge akan diambil. So in terms of what is the Q and also what is the time, travel time from the upstream moving to the downstream. Okay, so and then this is the Q, this is the watershed, and at the end dia akan bagikan kepada this type of hydrograph. Okay, so this is the hydrograph yang kita akan dapat. Okay, so and then let's say you have the river. Let's say in this case you have this river, you have the tributary 1 and you have the tributary number 2, and then what you would like to have here is you want to construct dam. Okay, so let's say this is the dam that you would like to have in this catchment area. So this is the reservoir. So basically whenever you do a dam, so what you try to do is you reduce dia punya Q peak. Okay, so you try to reduce the Q peak having the dam. So basically what are you going to introduce is you try to reduce what is the Q peak. And also whenever you have to tell the Q peak, so apa yang kita akan dapat, you punya peak discharge akan berada di sini. Okay, so this is the something that you akan dapat, Q peak based on the condition number 2. So this is the Q peak condition number 2. Alright, so you will have at the starting point and then end up dia akan naik secara yang sama. So this is the hydrograph. Sorry, so I think it's the salah di design. Okay, so basically dia akan naik. Okay, so dia akan sampai satu peak. Okay, so this is the time to peak. But at the end, bila kita compresskan benda ni on this part, on the falling limb, akan bergerak toward to the right direction. So what happened here is instead of you have the T base, instead of you have the time base. Okay, so this is the base time. Okay, so this is the base time. So make sure that you can recall the component in the hydrograph. Okay, so kita panggil dia sebagai TB. Okay, so basically bila kita push down the Q peak, so on the right side of the graph, which is falling limb, dia akan bergerak towards ke arah kanan. So moving to the right direction. So what happened here is your falling limb dia akan bergerak ke arah lebih cenderung ke arah ke sebelah kanan. Okay, so jadi your new base time akan semakin panjang. Okay, so this is your TB. Okay, because at the end apa yang akan berlaku adalah the volume remains same. So volume volume dengan dam adalah sama juga dengan volume dengan apa yang you buat sebagai volume existing. Because at the end you want to reduce the volume akan sama, because hujan, because basically whenever you design you propose a dam, because if you have that the same amount of rainfall will give you the same volume. And of course if you design using different queue, you increase the queue, dia akan lebih banyak lagi lah dia punya discharge dia. Tapi bila you reducekan dia punya queue peak, so dia akan lebih banyak moving ke arah sebelah kanan, dia punya falling limb. Okay, so this is kita panggil sebagai falling limb. Okay, so jadi kita punya TB akan lebih meningkat. So yang ini yang kita juga kenali dia sebagai on this graph, also kita panggil dia juga kita panggil sebagai modified. Okay, so modified hydrograph. Okay, because of the dam. Okay, so it depends if you want to go with the let's say if you want to go with the ada satu detention area di sini. Okay, so then you akan dapat benda yang sama juga. Okay, so detention pond. Okay, ataupun storage. Okay, so basically benda yang sama lah. So you basically what you have to do is you reduce you punya Q peak, but you akan increase you punya TB. Okay, so this is the easy correlation that you should understand whenever you do this analysis. Okay, so jadi area under graph is basically is the volume of the water lah. Okay, so yang ini if I'm not mistaken, you boleh recall balik kita punya minggu yang ketiga. Okay, last week minggu yang keempat saya bagi exercise, and then kita ada minggu yang ketiga tu kita ada rational method. And then rational method kita ada guna kaedah fee index. Okay, so kita calculate what is the losses yang berlaku, berapakah effective rainfall. So jadi dekat dalam tu kita ada calculation what is the Q. Okay, so area di bawah graph. So area under the graph, when you calculate, you akan dapat the area, and then bila you calculate dengan dia punya time, so if you have the 1 hour of the interval, so you type dengan time, so you akan dapat the Q lah. Okay, so that is the fundamental on the biasa punya kaedah. Okay, so basically bila kita dah ada this equation, so apa yang akan berlaku adalah kita akan introduce satu equation di mana kita ada standard equation, kita ada inflow minus outflow, so equal to storage. Okay, so equal to storage. So basically storage over delta T. Sebab apa? Sebab kita punya inflow and outflow, the unit is the meter cube per second, and this one also is meter cube per second. So this is the in term of volume, and the time of course into a second. So we try to get the consistent of the value by introducing the unit as well, the time. Jadi bila kita dapat dekat situ, apa yang akan berlaku, kita cuba dapatkan secara average. So jadi kita akan tengok kepada inflow 1 campur dengan inflow nombor 2, so kita akan bahagikan dengan 2. Okay, so kita akan tolakkan kepada outlet 1 minus outlet 2, so you divide into 2, and then you will get the delta S over delta T. Okay, so and then you bring this delta T into this the equation, so you akan dapat satu equation, so we call it as a general flood routing equation, and then you akan dapat satu equation I average 1 plus I2 divide by 2 and times delta T, and also minus outlet number 1 minus plus 2 and times delta T, and then equal to delta S. Okay, so because the delta T you bring into the left hand side, so this is the equation that kita akan pakai, yang general equation yang kita akan pakai for the rest on the flood routing. Okay, so basically this is the way how we come out with the flood routing. Okay, so jadi apa saja yang kita buat, basically apa yang bila kita katakan sebagai whenever you have the data. Okay, so for instance, let's say add another slide. Oh, sorry. Okay, so let's say you have the upstream data. and you get the downstream data, and then you can come out with the graph where you call it as this apa orang kata, so you have the existing, so where this is the upstream, and you also have the hydrograph where you modify, so this is the downstream. So this is, then you can call it as a, whenever this process you call it as a routing. Okay, so this is the flood routing analysis that you akan buat. So ini adalah secara general yang kita akan buat untuk membuat analisa. So if you introduce something, so apakah yang akan berlaku kepada sistem catchment kita. Okay, tapi sebelum kita pergi ke arah equation ataupun kaedah apa yang perlu diguna pakai, kita kena tahu dalam flood routing ni dah ada beberapa aspek. Okay, so dalam flood routing sendiri dah ada beberapa kaedah. So saya pecahkan kepada flood routing. Okay, so dalam flood routing ni kita pecahkan kepada dua. Okay, so yang pertama kita panggil dia sebagai hydrologic routing. So dalam hydrologic routing, basically ini kita panggil dia sebagai LAM model. Nanti saya akan ceritakan apakah itu sebagai LAM model. Okay, so and then yang nombor dua saya akan explain selepas ni adalah kaedah yang dikenali sebagai hydraulic routing. So in hydraulic routing kita panggil dia sebagai distributed. Okay, so distributed routing. Ini saya akan explain juga. Okay, before we go further, apakah dalam hydrologic routing, what is the method that we use in the hydrologic routing, and what is the method so-called in the hydraulic routing. So saya akan cerita what is the LAM and what is the distributed model. Okay, so nanti untuk LAM dengan distributed model ni saya akan kita akan jumpa balik dalam part modeling. Okay, so pertama kita akan tengok what is LAM, what is the distributed. Okay, so basically when we talking about LAM ni basically kita akan cakap secara overall. Okay, so distributed ni kita panggil sebagai very specific where kita akan tengok, for example, let's say if you have the catchment, okay, so and then you have the river. So what happened into distributed model? So basically you can get the information here, you can get the information here, so every single location that you can get. So it doesn't matter where is the location. So however, if for the LAM model, so the catchment area same, you only can get here. So as compared to the distributed, so you can have several locations where you can get what is the Q versus time. Okay, so this is what you call it as the hydrograph. Okay, so but for the LAM model, so basically this is only one outlet with one hydrograph. Okay, so basically this only that you can get the hydrograph here. But for the distributed model, so you have boleh dapat, let's say you have the number one, so this is the interested point, so that you like to come out with the hydrograph. So you boleh keluarkan hydrograph 1, hydrograph 2, hydrograph 3 and hydrograph 4. So you have several hydrograph that you can calculate. Okay, so this is the difference between distributed and the LAM model. Okay, so distributed and LAM model. Okay, so itu yang tadi saya ceritakan. So I mentioned about the hydrologic model. So basically kita akan kenali dia sebagai LAM model, and also for the hydraulic routings kita akan gunakan distributed models. Okay, as for now, ada soalan ke? Kalau you tak ada soalan, saya boleh teruskan. Tapi kalau you ada soalan nanti dekat mana-mana, nanti if you think that you would like to recall, so nanti you boleh bagi tahu dengan saya lah. Okay, so secara overall, when bila saya beritahukan sebagai overall, Okay, so bila saya beritahu sebagai overall dengan very specific ni, so meaning that so the whole catchment, so for the overall the whole catchment will only have one land use, one mining roughness, one soil type. Okay, so this is the things yang akan berlaku secara overall. So meaning that if you have, let's say you have the catchment area on the upstream, let's say ini adalah satu kawasan, and you have another area located dekat somewhere around here sebagai satu kawasan. Okay, so and then you have another part here as satu kawasan. Maksud saya di sini adalah land use, soil type, mining roughness akan berbeza. So what happened in the LAM model? So they will average. Okay, so and then represent only one value. So as compared to the distributed model, so exactly the same whatever we have here on the LAM model, but the thing is dia akan represent ikut apa yang ditulis. So for example, so for example kita ada kawasan, so we have this area on the left side, on the right side, and then you have the area here, and you also have another one here at the upstream. So let's say the exactly the same condition. So each of this area, so let's say you have the land use 1, so you have this as the land use 2, and you have the land use 3, you have the mining 1, so you have the mining 2, so you have the mining 3, you have the soil type 1, 3, soil type 2, soil type 1. Okay, so you have the specific at the different location. So the representation of the distributed model, which is the hydraulics part, hydraulics routing is more accurate to present, and then the analysis is more reliable. Okay, so that is the things yang kita kena tahu bezakan. So you have to understand, you should be able to differentiate between LAM and also distributed model. So this part kita akan the definition of the LAM and distributed kita akan guna, we will find, kita akan guna juga untuk flood modeling. Okay, so dalam flood modeling kita akan guna juga, kita akan jumpa balik benda ni. Okay, so dalam flood modeling. Okay, so dalam flood modeling nanti kita akan gunakan free software. So it's very light software, you can download. Kita akan guna HMS dan juga HREST. So nanti kita akan tengok bila masa kita pakai LAM, bila masa kita pakai semi-distributed model. Semi-distributed model is between LAM and distributed. Tapi the thing is, you should understand, setiap model untuk modeling, untuk flood modeling, so dia mesti akan ada LAM, semi-distributed, distributed or integrated 1D and 2D model. Okay, so nanti akan boleh nampak lah, ada yang guna pakai pipe modeling. Okay, so nanti kita akan go further on that when we go into the flood modeling. If I'm not mistaken, week 10 sampai week 14, if I'm not mistaken, kita akan masuk kepada flood modeling. Okay, alright. Okay, so this is the definition of the hydrologic routing, which is kita akan gunakan LAM model, LAM routing, and then untuk hydraulic routing kita akan gunakan sebagai distributed routing. Okay, and then after that kita kena tahu bila cakap pasal LAM model ni, equation yang akan diguna pakai adalah continuity equation. Okay, so this is kita akan pakai continuity equation, and then untuk kaedah hydraulic routing kita akan gunakan continuity equation plus momentum equation. Momentum equation ni kita akan panggil dia, kita juga kenali sebagai sign Venant equation. Sign Venant equation. Okay, so untuk siapa yang ada civil engineering, first degree dia civil engineering, dia mungkin dia dengar lah apa itu continuity, apa itu momentum, so what is the sign Venant equation. So even though you tak boleh nak recall sekarang, but nanti saya akan cerita sedikit sebanyak lah berkenaan dengan what is the continuity and what is the momentum equation. Okay, so in this case, sebab tu dalam analisa, when you do the analysis using the hydrologic routing, kita akan pakai satu equation saja, continuity. So the continuity equation, siapa-siapa boleh beritahu saya what is the continuity equation? Siapa-siapa yang tahu? Kalau tak tahu pun boleh give a try. Apa itu continuity equation? Ataupun bagi je equation apa yang diguna pakai. Ini memang you selalu pakai lah. As a civil engineer, you selalu pakai lah. Tak ada cakap tak pakai lah. Confirm you akan pakai.
Fluid dynamic, Doctor?
Tu dah advance sangat tu. Jadi equation ni, just give me the equation. What is the continuity equation?
Q1 equal to Q2.
Okay, alright. So the continuity equation is Q1 equal to Q2 and Q1 apa dia?
A1 V1.
Okay, so A1 V1. So you akan dapat juga A1 equal to 1 over N R 2/3 and S 1/2. Okay, so this is the continuity equation. It's very simple, very straightforward. Okay, you can get the location at the far end downstream. Maksudnya macam tadi saya bagi tahu dekat main outlet. So this is the only things that you can get. So the slope you boleh ambil daripada atas. So you ada elevation 1 and you have the elevation number 2 and then you have the length. So what is the length? So this is the total length. So and then you akan dapat dia punya slope. Okay, slope yang this is the slope. Bukan takut nanti you tertinggal, you tertukar dengan storage. So equal to E1 minus E2 over length. Saya kena tulis juga sebab ada juga pelajar-pelajar yang bila cakap pasal slope kita tak tahu. Okay, so kadang-kadang some people call as a slope, some people as the gradient. Okay, so the slope can be in term of percent, can be slope in term of apa orang kata tu meter over meter, because the elevation will be, the unit of the elevation will be meter, the length will be meter. So some people dia akan tulis slope sebagai katalah 0.016 ataupun ada orang dia tulis m over m. So sama saja, tak ada masalah. Okay, dia boleh panggil slope, boleh panggil gradient. Okay, so this is something yang kena saya tulis jugalah dekat sini sebab saya punya, because sometimes I assume that when talking about slope or gradient, I assume student will understand, but unfortunately bukan semualah akan boleh tahu what is the gradient, what is the slope, and even the equation I have to write in here because not all student can know how to calculate. Okay, so I just give you this. Okay, so jadi dalam continuity equation, so in this continuity equation ada Q1 equal to Q2, so Q equal to AV. So this is a very simple, very straightforward continuity equation. And then untuk for hydrologic routing, so basically you have another two method. Satu kita panggil dia sebagai reservoir routing, and another one is kita panggil dia sebagai channel routing. Okay, so this is the two equation yang kita akan pakai dalam kita punya equation. Okay, so dalam reservoir routing pula kita akan ada beberapa kaedah lah. So kita boleh gunakan kaedah modified pulse method. Okay, so you boleh juga guna pakai kaedah ini semua siapa yang ada degree punya ni dah belajar dah, Goodrich method. Satu lagi kaedah yang kita panggil dia sebagai yang ini dia panggil kaedah, I try to recall it apa dia, nama dia Ranggakuta. Okay, so Ranggakuta method. Okay, so Ranggakuta method. So yang ini lebih kepada numerical. Numerical meaning that kita tak boleh solve dengan menggunakan secara manual. Okay, so you have to use the software. Selalunya macam Ranggakuta ni, you have the algorithm where you can use either C++, you can use the R method, R software, you can use MATLAB, you can use Fortran. So this is the method that you can use. The software that you can use to do the Ranggakuta method. Okay, but however for another two method, which is the modified pulse method dengan Goodrich method, so basically ini ada dalam example buku Subramaya. So you boleh buka kaedah tu, and I think I will teach you only salah satu method sajalah. Okay, so nanti saya cerita kenapa nama dia sebagai reservoir routing dan kenapa nama dia sebagai channel routing. Okay, dia ada there is the specific, the reason why they call it as a reservoir routing and channel routing, because the way how they do the calculation, the equation has been the equation established, where they derive the equation based on the what reflect to the name of the routing, either reservoir or channel routing. Kalau channel routing ni selalunya kita panggil satu saja, kita panggil dia sebagai Muskingum. Okay, so Muskingum ni pun dia ada dua, satu Muskingum method, satu Muskingum Chungai method, tapi kita akan go for the Muskingum method sajalah. Okay, so and then untuk kaedah reservoir, kenapa kita panggil dia sebagai reservoir dan juga channel routing, kalau kita tengok nama dia, apa orang kata, sebagai reservoir routing. So satu lagi kita panggil sebagai channel. Okay, so basically whenever you have the route kepada dam, okay, so let's say you have structure and then you have the water level here. Okay, so basically whenever you have the water level, so nama reservoir routing ni adalah level pool routing. So this is the other name for this method, level pool routing. Okay, so the keyword is the pool. So basically pool ni nama dia kolam. So that is the reason why they call it as reservoir routing. So nama lain dia adalah level pool routing, because you have the water level here. So you have the water level here where basically what happen, dia tak begitu banyak perubahannya, walaupun dia Q tinggi tapi tak terlalu banyak as compared kepada channel routing. Channel routing, apa yang diguna pakai, apa yang berlaku adalah, you just imagine if you have one river, so moving upstream to downstream, so this is the upstream and this is the downstream. So basically kalau kita tengok, dia akan ada so-called wave sedikit. Okay, so bila kita panggil dia wave sedikit, and then kita akan ada satu keadaan di mana kita generalize. So this is the water level. Perasan tak? So if you can recall, whenever we do the analysis of in the channel, so kita akan constantkan dia punya water level. Okay, so whenever we do the constant of water level, so kita ambil just one section. So we do the analysis only one segment. So what happened in the one segment here is adalah, so you akan dapati ada sini dalam bentuk kita panggil dia sebagai prism. Okay, so prism storage, and then you call it dekat bahagian atas ni, so this is sebagai, kita panggil dia sebagai wedge. Okay, so this is the wedge storage. Okay, so whenever you have the wedge storage above the prism, so this is what you call it as a positive. And then whenever you have the below, okay, below the surface level, so kita panggil dia sebagai negative. Okay, so negative wedge storage. Okay, so basically this is adalah nama dia, kenapa dia panggil dia channel routing, because channel routing ni dia akan ada combination of the prisma plus on the wedge. Okay, so untuk dapatkan dia punya analisa dia, the analysis will cover on this section. Okay, so that is the reason why dia panggil dia sebagai channel routing, sebab kita fokus kepada on the channel, the river itu sendiri, as compared to the reservoir routing, so we focus on the reservoir. Okay, so this is something yang kita akan tengok. And then kenapa dia panggil reservoir routing pula, kita akan lebih consider kepada as a function the storage yang kita guna pakai, the storage that we consider into this analysis is a function of the outflow. Okay, so what is the kita consider on this part? That is the outflow that can affect to our area, sama ada flooded ataupun tidak. As compared to the channel routing, so channel routing ni basically kita akan tengok dia punya the storage that you have here is the function of the inflow and also outflow, because you have to consider what is the in of the system and what is the out of the system. So that is the reason you akan gunakan pakai dalam you punya analisa ni. Okay, so this is the introduction of the flood routing yang kita akan guna pakai untuk pada sesi untuk minggu hadapan hingga minggu yang dalam 2-3 minggu ni lah. Okay, alright. So that is about the channel hydraulic routing. So kita ada kaedah yang pertama dan juga kita ada kaedah nombor 2. So we have the reservoir routing. The first method we call it as a reservoir routing. second method as a channel routing. But if you look into the apa orang kata hydraulic routing, nanti kita akan tengok jugalah what is the method yang akan diguna pakai. Okay, so but somehow untuk hydraulic routing memang lebih detail because you have the continuity and you have also the momentum the equation. Okay, so that is about the method yang kita akan guna pakai. Okay, ada soalan berkenaan dengan topik yang kita akan cover untuk flood routing? Kita akan cover semua kita akan cover, tapi untuk but the reservoir routing we are not going to cover everything. Reservoir routing I will choose only one method as compared to 3 method that we have now. Okay, so on the hydrologic routing I will cover reservoir routing and channel routing, and then for the hydraulic routing on the distributed part, so I will cover only one method because we don't have enough time, and I will give you some of the example, detailed explanation on the example, and the example itself is come from the Sugamaya. Okay, so that is the method yang pergi mana-mana pun, whenever you go, that is the method that we always use. Okay, so but the things, the different is only either you want to choose the modified path method. It depends on the country. It depends on the which region that you use. Each region has the suitability, which method is more suitable that can get better result, either modified or Goodrich or Rangituta method, where you use the numerical approach to solve this problem. Okay, alright. So ada apa-apa soalan berkenaan dengan flood routing yang apa saya akan jelaskan selepas ni? I think selepas ni kita akan pergi kepada Mas Kingdom, if I'm not mistaken. Kita pergi kepada channel routing dulu. Ke you nak ambil masa bernafas sikit, fahamkan dulu sikit, recall balik sedikit. I can give about 5 minutes, no problem. Ada yang bertanya ke dekat dalam tu? Sebab saya bunyi macam ada something. Sebab saya tak boleh nak tengok apa yang ada dalam notes punya ni. Kalau ada soalan boleh siapa boleh baca ke?
Ada Doktor, Anis Syafiqah tanya, Doktor boleh terangkan semula what is prism and wedges and its function?
Oh, okay. Right, thank you so much. Sekejap saya buka balik. Okay. Kalau kita, nanti benda ni akan ada kat atas saya dekat dalam ni. Ni wedges dengan prism. Okay, so prism tu dekat bahagian bawah, wedges tu bahagian dekat atas. So this is the part yang saya akan cerita nanti. Tapi nanti kita akan pergi detail balik lah. So wedges dekat bahagian atas, prisma dekat bahagian bawah ni. Nanti saya akan cerita, kita akan masuk juga. Okay, ada lagi tak soalan berkenaan dengan topik ni? Nanti saya akan cerita detail. Sebab ni kita akan pergi kepada, yang ni kita on this part, this is the mass kingdom. So mass kingdom kita akan cover hari ni lah. So on 10 of November 2022 class. Okay, so ini akan cover hari ni. Yang ini on the reservoir routing, so maybe next week, but next week on the 17th is the, nanti kita akan tengok balik on the macam mana. Sebab 17 bulan 11 ni, I think kita ada pelepasan untuk pergi for mengundi. So nanti kita tengok how the 17th of November ni kita nak buat kelas ke ataupun tidak, macam mana. Okay, so kalau tak ada apa-apa soalan lagi, saya boleh masuk kepada slide berikutnya. Kalau tak ada soalan, kalau soalan saya jawab dulu soalan tu.
Tak ada soalan, doktor, boleh teruskan.
Alright, thank you so much. Okay. So, jadi kita akan pergi kepada kaedah yang berikutnya. So, we move into the next session. So, for those from civil engineer, background from civil engineering, I think ini hanya adalah sebagai ulang kaji ataupun to refresh lah basically apa yang you dah belajar. Okay, so tapi tadi saya dah ceritakan sedikit sebanyak the category of the flood routing that kita akan guna pakai. Okay, so ingat balik sebelum ni kita ada rational method, kita ada rational method. So where you have the Q equal to C kalikan dengan I kalikan dengan A. Okay, so and then you have the second, you have the frequency analysis. So you have the frequency analysis, and then now we have to go the flood routing. Okay, so basically kita ada tengok on the Q on the first method, this is what you call you calculate for the Q, and then this is to determine what is the Q, and this is you want to determine what is the Q after you propose the method that you would like to go. Okay, alright. So this is the learning outcome. Ejaan salah. So LEAR, so learning outcome. So you should be able to differentiate, to apply Muskingum, and you should be able to differentiate between these two methods. Okay, tapi saya rasa saya akan pergi go for the Muskingum sajalah. Okay, so because not much different between Muskingum and Muskingum cuma method, so tapi saya akan pergi kepada Muskingum saja. So on this part, okay, so I will go with this. Okay, seperti yang saya telah explain, sebenarnya ini adalah kita panggil dia sebagai gradually varied and unsteady flow. So basically as a civil engineer, sebelum ni saya dah bagi tahu kita akan ada jenis flow type. Okay, so kita cakap berkenaan dengan flow type. Jadi kita akan ada berkenaan dengan in term of space. So and then in term of time. Okay, so jadi bila kita cakap pasal berkenaan dengan space, so jadi kita akan tengok kepada dua, kita boleh cakap sebagai uniform and you call it as a non-uniform. Okay, so non-uniform. Ini just for the ulang kaji lah, for the yang civil engineer. So kalau uniform, uniform basically throughout the section of the river, you akan dapat same height. Okay, so you pergi daripada, let's say this is the 1 meter at this point. So this is the point A and this is the point B. And you akan dapat 1.0 meter as well, the water depth. Okay, but if you go into, let's say you go from point A to point B, so the water depth decreasing. Okay, so you can see this is the point A. So let's say you have the 1.0 meter and this is the point B. Your water depth is let's say 0.7 meter. Okay, so the water depth is not constant throughout the channel. Longitudinal meaning that you have from upstream to downstream. Okay, if you look into the cross section, you look into the specific location at point A, so you look into the cross section. But if you look into the from from upstream moving to downstream. So you look into the side of the river. So we call it as a longitudinal. Longitudinal. Okay. So this is you call it as a uniform, and this is what you call it as a non-uniform. Okay. So this is in term of space, because space ni kita tengok dari segi in term of place. So now kita tengok kepada in term of time. Okay. So in term of time, so maksudnya you do the analysis, you look into the specific area. Okay. So let's say this is the point A, but you stay at location. Let's say you have at 8 in the morning, 9 in the morning. So you have at 10 in the morning, just at the specific location. Okay. So the water depth at 8, let's say you have at 1 meter. So this is also 1 meter. This is also 1 meter. So this is what you call it as a steady state condition. Okay. So and then if 8 pagi, so if at 8 in the morning you have 1.0 meter, 9 in the morning you have 0.8 meter, and then 10 in the morning you have 1.1 meter. So this is what you call it as a unsteady. Okay, so now you have the in term of time and also in term of space. Okay, time ni you just sit at specific location daripada pagi sampai ke petang. Okay, daripada 8 pagi sampai pukul 8 malam, you stay at the one location and then you measure. Not only the water depth, you can measure also in term of velocity. You also can measure the discharge. You also can measure the there is the parameter yang kita selalu tengok lah bila kita nak cakap pasal flow type. Okay, but if you move you put into the space, let's say at the point A and point B, kita tengok kepada on the space. So if you want to look into the space, so you akan perlukan 2 orang. Okay, pada pukul 8 pagi, these 2 person akan ambil data dekat point A and point B and then do the comparison. So bila they do the comparison, so the water depth, discharge, velocity sama, so maksudnya dia dalam keadaan uniform. But if these 2 observer ataupun technical punya person do the observation and then find out that at pukul 8 pagi data tak sama, okay, sama ada 1 meter, 7 meter, semakin meningkat ataupun increasing or decreasing the value, the observed value, so meaning that you have the non-uniform condition. Okay, so basically kita akan cakap sama ada secara uniform ataupun kita akan cakap unsteady, non-uniform, ataupun kita cakap steady, non-uniform. So dia ada combination in term of space and also in term of time. Okay, so in this case kita akan buat kepada analisa untuk Muskingum. So kita akan tengok, kita assume dia sebagai gradually very unsteady condition. Okay, so ini adalah condition yang kita akan tengok untuk gunakan Muskingum. Alright, so tadi one of your colleague tanya berkenaan dengan wedges. So basically is the water in the channel has the parallel to the channel. Okay, so parallel to the channel, kalau kita tengok tadi saya bagi tahu, saya lukiskan. So this is the riverbed. Riverbed maksudnya bottom of the river. Okay, so and then you have the flow. Okay, so basically kalau kita tengok satu section, so if you look into the one cross section, so this is the prism and this is the wedge. Okay, so basically kalau kita tengok on this part, apa yang akan berlaku adalah kita tengok when we take, this is the point 1 and this is the point 2. So if you look into the inflow, okay, so this is the inflow. So this is the Q in. Okay, so this is also the Q in. So you can see there is the different in term of drawing. Okay, so there is a different in term of drawing. Kalau tengok di bahagian bawah tu, dia akan dalam bentuk prisma. Okay, so dalam bentuk prisma. So basically, okay, so this is the way how they look. So prism. Okay, so and then another one on top of it, dia akan ada satu lagi. So we call it as a prisma on the wedge. So jadi dia akan bentuk segitiga. Okay, bentuk triangle. Okay, so this is they call it as a prisma wedges. Okay, so this is wedge. Okay, so bila kita combine tu, dia akan dapat on this part. Okay, so this is the segitiga on the wedge and bawah ni on the prisma. Okay, so this is the prisma and on the top is the W, is the wedges. So this is the definition yang kita akan tengok. Kita akan tengok from one section to another section. Okay, so ni yang kita akan tengok sebagai the total volume in the channel wedge. Kita akan tengok secara prism and also secara wedge. Okay, so this is the better explanation lah kalau kita tengok on the prism. And this is the explanation on the wedge. Okay, so far okay ke tadi yang ada yang bertanya saya soalan tu? Alright, no problem. Okay, so jadi bila kita gunakan sebagai prism, so kita ada SP. So this is the storage of the prism. Okay, so storage prism. So kita buat storage denote SP, and then on the SW is the storage of wedges, of wedge. Okay, so kita akan denote dia sebagai SW. Okay, so kita ada SW, so kita ada S function of the Q, S function of the inflow. Okay, so because you have to remember this is the channel routing. Okay, so channel routing, the storage, saya mention tadi, so I mentioned about the storage is a function of the inflow and also outflow. Okay, so that is the reason why you akan nampak dekat sini dia akan ada inflow and also dia ada outflow. Okay, so jadi bila kita masukkan sebagai storage, ada orang nak masuk ke? Saya dengar macam ada ni. Tak ada Ataupun ada question ke nak tanya? Tak ada ke? Sebab saya dengar ada bunyi macam ring, macam clicking, macam apa, bell, macam nak tanya soalan ke ataupun ada student nak masuk. Kalau tak ada tak apa, it's okay. Okay, so jadi kita ada total storage, itu summation of the SP plus dengan SW. Okay, so dia akan dapat on that equation. And then kita akan tengok kepada K, so the K value and X coefficient, M is a constant. So K and X you can calculate. So you can calculate, but M is the constant value, but it depends on what is the value that you use. Either you go with the rectangular channel or you go with the natural channel. Okay, so rectangular channel, so as simple as you have the rectangular shape. Okay, so this is the rectangular punya shape. So for the natural channel basically is the irregular. So basically you akan simplify into the trapezoidal. Okay, so this is the rectangular, so this is the trapezoidal. Trapezoidal shape. Basically on the natural channel, you akan nampak dia punya shape dia basically is irregular, but when you simplify, so you akan dapat bentuk yang hampir menyamai ke arah trapezoidal. Okay, so trapezoidal doesn't mean that you have the slope 1 and slope 2 is same. Okay, so tak sama. Dia boleh jadi sama or cannot be same. And you have to, satu lagi, since I mentioned about the slope, so bila cakap dalam equation ini just to remind sajalah, because sometimes I give the question, I always mention about side slope and slope of the river. Okay, so this is two different slope. And in the equation, in the Manning equation, okay, so in the Manning's equation, okay, so you have the velocity, so equal to 1 over n, so r 2/3 as 1/2. Okay, so this slope is referred to the channel slope. Channel slope refer to item number 2. Okay, so this is the one that you have to refer, not as a side slope. Saya bagi tahu ni sebab ada student, I think banyak jugalah student, I cannot say what is the percentage, but some of the student, they put the S0 as the side slope, which is wrong. Okay, the side slope is on this part. So this is the side slope. Okay, so this is the side. So this is the side. And for the bottom, that is okay, so on this part, so this is the number 2. Okay, so this is the slope of the river. So meaning that we have to do is, macam tadi saya bagi tahu, you have the channel, you have the catchment area, so you have the elevation 1, so you have the elevation 2, and you have the length here. So then based on this E1, E2, and L, so this you can calculate what is the slope. So this slope basically is referred to the slope number 2 here. So I think I draw a lot of things, I give the information a lot of here. So I think I hope you can understand, you can differentiate between side slope and slope of the river, or channel slope, or bottom of the river. I don't know what is the other's name, but when I mention the side slope, kita akan tengok kepada on the side of the channel itself. Okay, so on this part, this is the side because dia terletak di bahagian tepi. Okay, so side tu bahagian tepi. So that is the, you should be able to baca lah. Sila baca soalan tu betul-betul because dia akan ada. Selalunya soalan-soalan untuk soalan sini saya tak bagi dalam bentuk image, dalam bentuk figure. Selalunya saya akan bagi dalam bentuk text. So you should be able to translate, you should be able to draw untuk pastikan you boleh jawab lah. Sebab after all, bila you bekerja nanti pun, whenever you want to design, the information is not given to you as the drawing macam ni. It's very rare you can get that. So basically what you have to do, you have to go to the respective agency, any responsible agency or any local authority or any department. So they will give you, okay, this is the trapezoidal shape, so the side slope macam ni, the back slope macam ni, so dia akan bagi the value, so and then you have to translate from whatever the information that you get from the person, from the engineer, or from the technical person, so you have to translate into the drawing. So if you wrongly translate, so apa yang akan berlaku, you akan salah masuk value. Okay, sama macam tadi yang saya beritahu berkenaan dengan item nombor 1 kita tadi, yang bila kita discuss sebelum kita first half of the lecture, yang kita discuss berkenaan dengan nombor 1, equation yang dimasukkan, equation yang you transfer daripada kertas soalan masuk ke dalam you all punya kertas jawapan. So kalau dah salah transfer, tersilap value, tersilap simbol, tersilap equation, so nanti you akan salah calculate. Okay, so ini adalah constant untuk M. Okay, kalau kita tengok rectangular channel, kita pakai about 0.6, and untuk natural channel, ataupun kita boleh cakap sebagai trapezoidal channel, kita boleh panggil sebagai N equal to 1. Okay, so dalam this case, kita kena ingat jugalah, dalam this case, bila kita pergi kepada site, bila kita buat secara design keadaan yang sebenar. Okay, dalam slide sekarang saya tunjuk ni, this is the theoretical value. Okay, so if you go to the site and you want to design what is the storage dengan menggunakan equation yang ada, yang saya tunjuk sekarang ni, let's say we want to use this equation. Alright, so the M value, it depends on either rectangular or natural channel. Okay, so if the question given you as the trapezoidal channel, so even though the M value stated here as natural channel, but you should understand that this is the natural channel provided we mention ada grass, maksudnya dalam keadaan natural. Tapi kalau if we mention as the trapezoidal with concrete, okay, so with concrete, so meaning that this is not natural anymore. So the M not equal to 1, M not equal to 0.6, but you have to calculate, you have to determine what is the M value and what is the value for trapezoidal channel or trapezoidal concrete channel. So you cannot simply take, since I mentioned about the rectangular channel, is the rectangular channel can reflect to natural channel because you do the simplification, but whenever you go outside, bila you bekerja secara yang sebenar, you tak boleh nak ambil sebagai all trapezoidal channel, trapezoidal shape as the natural channel. You have to know what is the materials. Kalau materials dia banyak rumput, memang natural, maksudnya memang sungai secara semula jadi, so then you can use M equal to 1. So after all, kalau tak, you akan gunakan secara konkret. Tengok apakah value dia. Dia akan ada keluarkan table, dia akan bagi what is the range for the rectangular channel, what is the trapezoidal channel, what is the natural channel. So apa sajalah materials pun dia akan bagi. Okay, so jadi sekarang ni ini satu contoh kalau kita tengok if. So if kita go for the natural channel, so M kita akan pakai sebagai 1. Okay, so jadi S bila M sebagai 1 dalam previous equation kita ada M di sini. Okay, so kita ada M. So kita ada M. So Q power of M, I power of M. But since you have the power of 1, so you have the power of 1, so power of 1. So what happened here adalah dia akan menjadi very simple sajalah. Dia akan dapat linear relationship. Tapi kalau kita ada M equal to 0.6, 0.3, so it's not a linear relationship anymore. Dia akan menjadi satu equation yang orang panggil dia sebagai exponential function, quadratic function. Okay, so it depends on what is the M value yang diguna pakai. Okay, so jadi X punya value, so this is the weighting factor. X equal between, it can be between 0 to 0.5. Yang ini pun we will determine. So you can calculate here. So you can calculate or determine. Okay, so when storage, let's say you calculate as X equal to 0. So whenever you have the X equal to 0, so this is 0 and this is 0. So at the end, you akan simplify into the equation. So you akan dapat S as a function of the K and Q. And then K you have to calculate and then you akan dapat as a linear storage or linear reservoir. So maksudnya forward relationship. So it's just a matter of your K. Okay, so it's just a matter of K. So kalau kita tengok X tu sebagai 0, but it's very hard to get X equal to 0. Selalunya X tak akan dapat sampai 0 sebab we have to remember sungai ni dia tidak bertindak secara berapa Q masuk, itu yang akan dapat Q di hujung sana. Tak, selalunya kita akan dapat the discharge at point A, the discharge at point B will be different. So, but if you measure in the short distance, katalah setakat 2-3 meter, yes, you akan dapat benda yang sama. Tapi bila you over some distance, let's say you design for, you measure for maybe 100 meter apart, so you akan dapati dia punya Q akan berbeza. Mungkin Q tu berbeza tidaklah sampai 50% or 100% different, maybe about 20%, 30%. But when you accumulate, I mean when you measure along the channel from point A, point B, point C, point D sampai ke bawah with the 100 meter interval, you akan dapati dia punya Q akan berbeza. Dia tak selalunya sungai ni memang akan dapat Q yang berbeza, dia bukan Q yang sama. So it's very natural punya condition, selalunya tidaklah berlaku X equal to 0. Okay, alright. So this is the something yang kita dah buat sebelum ni. Okay, so ini yang saya katakan sebagai continuity equation yang kita buat. Apa orang kata tu yang saya ceritakan tadi tu. Okay, so kita pakai this is the general equation. Okay, so general equation yang saya explainkan tadi tu. So you ada I1 plus I2 delta T over 2. So basically sama jugalah yang saya lukis tadi. Okay, so basically what happened here is kita dah tahu whenever kita buat calculation, kita nak tentukan what is the inflow, what is the outflow. So whenever you have the inflow data, and then using this masking gap approach, and then you will plot what is the outflow. So bila you dapat you punya outflow, bila you plot, you akan dapati dia akan ada lagging, you akan dapat attenuation. Okay, so attenuation ni different between Q peak 1 plus Q peak 2. So maksudnya you have this is the Q peak 1 and you have at the bottom here, so this is the Q peak number 2. Okay, so that is the attenuation, and then you also can determine what is the lagging in terms of time. Okay, so you have this is the lagging. So you have the TP1 and you also have the TP number 2. Okay, so you can get what is the lagging. So you get TP1 minus TP number 2. Okay, so then you can dapat the lagging. So this lagging is very important. The attenuation also is very important. So by introducing any structure that you would like to have, so you akan boleh tentukan what is the attenuation, what is the lagging. So how fast, I mean how much of the volume of water yang you boleh kurangkan. Okay, because basically the reason why some of the area Q dia tinggi. Okay, so let's say kita ada satu channel. Okay, So let's say this is the maximum Q. Q max. Let's say you akan dapat katalah 10 meter cube per second. Okay, so whenever you do the attenuation, you try to reduce Q. Maybe what you have to do is, let's say this is adalah point A. Okay, tadi kita ada buat point B. Okay, so you want to have the travel from point A to point B. So you have to make sure that at the point B, the water level reduce as goes to Q peak as well. Let's say dapat 8 meter cube. Okay, so 8 meter cube per second. So this 8 meter cube per second, so you have the difference about 2 meter cube per second. So this is the attenuation that you like to have. By apa yang you akan buat, you akan tukarkan dia punya base time. Ingat tak? So if you still can remember, so the Q peak, you try to compress dia. So in order untuk dapatkan TB pun lebih tinggi lah. Maksudnya dalam sungai tu dia akan jadi lebih panjang lah. Dia punya volume tu akan berada di kawasan tersebut. Okay, so that is the things yang you perlukan. Attenuation and also the lagging. Alright? Okay, so yes.
Time base tu yang between T1 dengan TP2 tu
Tak, itu lagging.
Lagging yang
Base time tu yang total hydrographnya ni. Yang ini. So ni.
daripada yang first sampai yang modified tu. Ujung.
Maksud meaning that kita ada hydrograph satu dan kita ada satu lagi hydrograph. Okay, so ini hydrograph satu lagi tu. So kita akan ada satu TB yang warna merah dan juga TB yang warna hijau. So basically TB warna hijau lebih besar daripada TB warna merah. Boleh faham? Okay, so ini yes, this is the one that I mentioned to you earlier about bila you try to compress, bukan compress lah, you try to reduce, so suppress the QP instead of you have the existing condition and then pergi kepada if you introduce some mitigation measure. Okay, so itu yang you kena buat. So in order to get the existing condition, itu yang tadi yang kita buat last 3-4 minggu sudah. Okay, gunakan Q equal to CIA and then gunakan frequency analysis. That is about the existing condition. Okay, when you do the lagging, when you introduce any flood mitigation measure, so you reduce the Q peak into the Q yang you nak. So jadi you akan tengok berapa jauhkah yang akan berlakunya lagging dan bagaimanakah falling limb dia akan berlaku. Dan selalunya falling limb ni dia akan jadi lebih landai. Lebih landai tu maksudnya dia akan mengembang di bahagian bawah. Maksudnya it will spread out on the, let's say ini adalah dia punya condition existing, and then bila you introduce dia punya when you introduce the system, so apa yang akan dapat, dia akan start lebih landai. So, tapi dia akan lebih masa lebih lama lagi lah. So the volume adalah sama. Volume biru, volume hijau and volume merah adalah sama. So dia akan sama. Dua ni adalah sama. Same. Okay, cuba you compresskan dia, but you expand dia punya shape of the rising and also falling limb. Okay, so this is something yang kita selalu buat. Every single flood mitigation measure, they try to do this. So they don't want to have very fast high peak. They try to slow down. At the same time, they try to reduce the high peak, the peak. At the same time, you punya graph tu akan lebih ke bawah, dia akan lebih kembang. So it will expand on the bottom of the bell shape tu sendiri. Okay, dia punya graph. Okay, so this is the way how you do the analysis. Kita akan tengok satu persatu nanti macam mana kita nak buat on the X and then also on the K punya value. Okay, so K punya value, this is the equation kita akan guna pakai, and then you have to try. Okay, so maksudnya untuk X 0.2, 0.22, 0.25 and 0.3, so all the X adalah try and error. Okay, so you have to use the try and error. So Microsoft Excel is very easy, so you just can simply use the Microsoft Excel and then akan dapat lah what is the K and what is the X value. Okay, so the K value is basically is the slope. Okay, so dah ditulis di sini juga. Okay, so K value is the slope of the equation yang diguna pakai. So this is the slope. This line is the K, so jadi dia akan dapat K value. Okay, so jadi macam mana kita nak buat on the X, kita akan tengok satu contoh jugalah. Okay, saya tunjuk tengok dia punya X. Okay, so let's say kita ada satu question di sini. Example, kita ada satu example. Ini data yang diberi dalam soalan. Okay, so kita tengok example yang nombor satu ni lah. Okay, so kita ada inflow. So this is the I and this is O. Okay, so and then dalam this case kita ada I, kita ada O, and then kita boleh tolak gunakan equation. I tolak kepada Q, and then kita ada average, and then kita ada kalikan dengan time. Okay, so and then kita akan dapat S summation of the storage. Okay, so on this part kita gunakan this equation K. Okay, so on this part kita akan gunakan this equation untuk dapatkan dia punya on the part untuk bahagian y axis, and this is on the x axis. Okay, so basically it's come from this figure, come from this. Okay, come from this. So jadi apa yang kita akan buat on this part, so this is basically is the y axis. Okay, so this is on the x axis. So when you do this plotting, so you have to try with the macam for example for this case you try with the 0.35, 0.3, 0.25. You can go with the 0.2, you can go 0.1, you can go 0.5. So you can choose whatever you want. So but at the end you have to plot this image. So at the end your image ni dia akan dapat bentuk dia seperti ini. So and then you have to get very close to this line. Make sure that close to this line. So kalau for example kalau kita tengok, if I can make it bigger. Okay, so kalau tengok, if you look into this image, okay, so you have three different of axes, four different of axes. So jadi you akan dapat 0.22, 0.35, 0.3. So if you use smaller value of x, so of x, so dia punya shape ni getting closer to this line. Okay, so you akan dapat x equal to 0.2. So daripada 0.2 baru you boleh calculate what is the k. Okay, so baru you akan dapat slope of this line. So you akan dapat k and with x value dia berapa. So this one pun you akan dapat. So this is the slope. Okay, so this is from the trial and error. Okay, so you akan dapat that. So this is the basically for based on this example, because this example basically to us you have to estimate what is the k value and what is the x value. Okay, so and then itu satu. So basically this is the first part of the calculation that you have to do, and then on the second part calculation that you have to do is to determine the storage. Okay, so you have to use this equation. So this is the continuity equation that I mentioned to you. Okay, so this is the continuity equation, the general equation that you use. Okay, so that is part of the storage, and then the combination you akan gunakan Q2. So the Q2 is this equation. Okay, so you don't have to worry all the equations saya akan bagi. So kalau saya nak keluarkan soalan ni saya akan bagi. So Q2 apa, C1 apa, C2 and C3. So this is something that saya akan bagilah. Okay, so dalam this equation, in this equation K and X, so this is from graph. So this is the graph that you get yang you draw macam ni. Okay, so this is the graph that you get from here. Alright, so and then you have the C0, C1 and C2. So this is the general check. General check. So make sure that the summation of the C1, C0 and C2 is equal to 1. Okay, so some of you might be use the equation apa orang kata, you gunakan C0, you calculate, you akan dapat satu value, and then you calculate C1, you calculate, and then you akan dapat satu value. So what you can do, apa yang pelajar selalu buat adalah C0 plus C1 plus C2 equal to 1. So you calculate C2 equal to 1 minus C0 minus C1, which is 1 minus A minus B. You can do this if you believe your confidence about the value of X value of K, value of delta T is were choose correctly. Kalau you salah calculate, what happen adalah you akan salah dapat you punya C2 punya value. Okay, I know this method is very easy, very straightforward, where you only calculate on the C0 and C1 only. But the problem is if you wrongly choose, if you wrongly press calculator, if you wrongly put the value, okay, so you salah masuk value of K, value of X. So what happened is, let's say the C0 supposedly adalah 0.4, C1 katalah 0.3. So C2 exactly lah, kalau you tolak dekat sini you akan dapat about 0.3 lah. Okay, so let's say this is the value. Tapi because of you wrongly calculated, you salah tekan calculator, you akan dapat the value ni adalah 0.35. This value is 0.45. Okay, and then you apply the summation of the C's, you akan dapat 1.0. Jadi bila you tolakkan, apa yang akan dapat di sini adalah C2 equal to 1 plus 0.35 minus 0.45. So whatever calculated value here, you letak at this part, you akan dapat value, but it's basically it's wrong. So my suggestion is you calculate for every single C0, C1 and C2, then you check using this equation. Okay, so if the calculated value not equal to 1, so something is not right within your calculated of the C's value, C1, C0 and C2. Okay, so because this question basically is very easy, it's very straightforward. This is no such that you have to gunakan derivation ke apa ke tidak, but it's just a matter of bila you buat, dia akan jadi lebih tedious dan penat lah, itu saja. But other than that, it's very straightforward. Okay, so please kalau ada kalau katalah saya keluarkan soalan macam ni, ataupun you jumpa di mana-mana yang you kena gunakan masking approach to calculate the flood routing untuk dalam channel punya routing. So jadi what you can do is make sure that you masukkan data tu secara betul. Okay, so maybe what you can check before you masukkan equation, before you use the data, observe data for your study area, what you can do is, since you have this exercise, you have this example, and you also have the example from the book as well. So what you can do is you can use the examples with the solution, put into your Microsoft Excel, so and then you can recheck either the calculated value that you calculate using the Excel sama ataupun tidak. So if you get different answer, so something is not right with your calculation. Okay, so maybe you can check one is using the Excel and the other one is using the just manual calculation. Make sure that the equation is betul, and then the value yang dipilih KX and also delta T also betul. Okay, so once you dah confirm your C0, C1 and C2 is correct, apa betul, so then you boleh dapatkan general equation dekat atas ni lah. Okay, so basically this is the general equation. Okay, so this equation is sama dengan equation yang ini. This is more into general. Okay, so masuk general di sini adalah the equation is Qn equal to C0 In plus C1 In minus 1 and then plus C2 Qn minus 1. So if N equal to 2, so you akan dapat Qn, Q2, so equal to C0 I2 plus C1, so I2 minus 1, and then plus C1, C2, and then Q2 minus 1. So on this part, you akan dapat I1, on this part, you akan dapat Q1. So itu yang ada di dalam equation ni. Okay, so on this part. Okay, so saya tak bagi equation ni, tapi saya akan bagi equation di bahagian bawah. Because this is the general equation. Okay, so it's just a notation saja. Because saya jelaskan di sini, ada some of the student bila tengok apa orang cakap tu sebagai huruf ni. Okay, so huruf N, ada N minus 1. Okay, so I think kalau dalam ada some of the equation, dia ada N minus 2. Okay, so dia, if you don't familiar with this type of equation, nanti you akan rasa macam banyak sangat nak kena buat. Okay, so tapi sebenarnya you masukkan satu persatu, you tengok if n equal to 2, so then you akan dapat apa dia. So you masukkan on this part satu persatu. And then you boleh practice. Okay, so basically soalan-soalan macam ni selalunya dia straightforward. Satu, saya ulang balik. And satu lagi, even though you faham apa yang saya explain, so even though you can see my handwriting dekat dalam ni pun mungkin boleh nampak, boleh faham, but if you didn't do the exercise, so you akan dapat masalah nanti bila untuk soalan-soalan ataupun masalah bila you nak apply dalam you punya engineering work nanti. Okay, so my suggestion is I strongly recommended that you can redo the example in order to improve your understanding. And if you have any questions, so probably you can ask waktu perjumpaan kelas yang akan datang. So please make sure yang benda tu you buat dululah. Sebab after all kalau you tak buat, memang you tanya soalan pun memang tak ada jugalah. Okay, so this is the procedure. Saya tak pergi secara detail lah pasal procedure. So you punya delta T, okay. So delta T make sure mesti berada lebih daripada K dan mesti kurang daripada K dan mesti lebih daripada 2K kali dengan X. Okay, and then you calculate on the C0, C1, C2, and then you start buat masukkan satu persatu, and then you boleh repeat lah all the step. Okay. Alright, so this is the example number 2. Kalau tengok kat dalam ni pun memang saya dah buat secara detail lah on the solution ni. So you boleh tengok secara detail. Saya tak perlu nak explain. Okay, so at the end macam saya beritahu tadi, at the end all these values should be equal to 1 summation. Okay, so it should be 1.0. Okay, so and then dalam ni pun ada apa orang kata tu, so I did keluarkan dia punya sample. Okay, so ni semuanya buku daripada buku Subramania lah saya keluarkan supaya you boleh nampak bagaimana benda tu dapat. Okay, so macam mana dikalkulate. Alright, so yang ini pun sama juga, satu persatu saya keluarkan. Okay, so macam mana dikalkulate. Okay, so I think boleh tengok balik yang macam step, what is the step number 1. Okay, so you boleh pergi tengok step number 2, step number 3 and step number 4, and then step number 4 ni refer balik ke atas. So this is something yang boleh refer semula lah. Okay, so macam in this case saya just tunjuk satu contoh secara general sajalah. Kita gunakan pen orange. Okay, tak ada. Okay, so kita tengok dekat sini, kita tengok dekat sini antara 0 hingga 6. So in between these two value. Okay, so kita ada I 10 dengan 20. Okay, so jadi kita tengok kita ada 10, 20 dan Q1 kita adalah 10. So this is the Q1. Okay, so kita ada Q1 10. So kita ada dapat kat sini C1 kali dengan I1. Ingat kita ada equation kita adalah Qn equal to C0. Okay, so tadi equation yang sebelum ni C0 In. Okay, so kita ada equation C0 In plus C1 In minus 1 plus C2 Qn minus 1. So if n equal to 1, so apa yang akan berlaku adalah Q1 equal to C0 I1 plus you have the C1 I1 minus 1 is 0, and then you have the plus C2 Q1 minus 1 is 0. So meaning that the Q0 and I0 is the previous punya data. Okay, so sebab you looking at the Q1, okay, so you want to calculate at the Q1 dekat sini mungkin dah diberi kot if I'm not mistaken. Okay, so basically katalah you ambil ni sebagai Q1, so this is the number 1. Okay, so jadi you boleh nampak dekat sebelum ni dia akan ada Q0 0, jadi kita akan ambil value tu sebagai Q0. Tapi kalau in this case kita nak tengok ni sebagai nombor 1, so jadi Q0 dia sebagai 0, this one tak ada. So because Q0 here is 0, tak ada value yang sebelum, unless given dalam soalan dibagikan sebagai Q0 adalah 0. Okay, so yang ni ada tulis So the start of the inflow flood the 10. So jadi ini adalah Q0. Okay, so jadi bila Q0 ada 10, jadi boleh masukkanlah dekat dalam ni bukan kosong lagi lah. So dia akan jadi 10. So not 0 but Q0 equal to 10 meter cube per second. Okay, so you masukkan di code equation, so you akan dapat jawapan dia. Dapatlah nanti juga jawapan dia. Okay, so sama juga untuk 6 hingga 12. Okay, so boleh tengok jugalah macam mana dia punya calculation is step by step, satu persatu boleh tengoklah punya value dia macam mana, apa yang akan hasil. Okay, so that is about the Muskingum punya method lah. So Muskingum punya method ni dia lebih banyak equation dia lebih panjang lagi. So sebenarnya Muskingum dia lebih kompleks sebab dia melibatkan penggunaan space and also in term of time. So jadi dekat sini dia lebih detail dia punya analisa. So saya tak nak so I think I'm not going to cover lah untuk Muskingum Cungai method ni. Saya akan pergi stop setakat Muskingum Cungai saja. Okay, so at least you dapat the idea macam nak jawab. And satu lagi kalau tengok dekat bahagian on the solution of this, okay, so on this part you akan ada N dan you akan ada J. Okay, so jadi bila kita tengok J dengan N ni, apa yang akan berlaku adalah you akan tengok kepada satu lokasi. Let's say kita ada satu lokasi, so this is the point. So kita akan cakap sini sebagai J and sini sebagai N. Okay, so N kita akan moving daripada satu point kepada satu point. Okay, so this is the another J. So this is the J1. So this is J number 2. This is N1. So you have another part. Okay, so this is the N2. Okay, so in this case, let's say you have the N equal to 1, J equal to 1. So you akan gunakan moving secara horizontal. Habis J1, you pergi ke 2, 3. Dah habis 3, baru you pergi kepada J equal to 2, N equal to 1, 2, 3. Dia lebih kompleks, lebih detail lagi analisa dia. Okay, but you can try, no problem. Okay, so ada some of the example dekat dalam ni. Yang ini, so this is the one of the example. Dia boleh tengok on the, I think this example pun datang daripada buku sebelah maya jugalah. Okay, so tapi saya tak nak cover on this part. Saya hanya akan cover kepada up to the Muskingum method ni saja. Okay, so kita akan stop dulu di sini untuk channel routing untuk minggu yang kelima ni. Okay, so next week adalah minggu yang ke-6. Jadi next week ni ada soalan ke nak tanya berkenaan dengan on this lecture punya malam ni? Ada soalan ke? Tak ada soalan ke? Dengar ke tak dengar?
Tak ada, doktor.
Okay, so kalau tak ada soalan, I think you all ada dapat notice kan bahawa start from 17 ni kita tak ada kuliah kan, sebab student diberi kebenaran untuk pulang awal balik kampung untuk student mengundi. Okay, so tapi 17 tu adalah hari Khamis, which is our class. Saya nak tanya you all nak buat kelas ke ataupun tak ada kelas? Sebab nanti kita kena ganti juga nanti. Ataupun satu option kita buat kelas, second option tak perlu buat kelas tapi kena ganti. Ataupun saya bagi exercise macam last week berkenaan dengan topik hari ini, dan juga maybe some additional exercise on the rational method. Mungkin satu ataupun dua rational method, satu ataupun dua berkenaan dengan Muskingum. And then you boleh buat and then submit dalam future. Saya buat benda yang sama, saya akan download dan saya akan lihat, saya akan komen secara general. Apakah something that I think that you should improve. So which one do you prefer? Nombor 1 ke, nombor 2 ke, nombor 3?
Exercise tu.
Okay. Okay, so
Exercise.
Nombor 3.
okay, so ramai lagi ke nombor 3?
Nombor
Ada
3
lagi?
juga doktor.
Ada yang nak selain daripada nombor 3 tak? Saya tak ada masalah, saya okey je. Mana-mana pun boleh.
Diam tanda setuju doktor.
Apa dia? Oh, diam tanda setuju. Okay. Okay, so if that is the case, nanti saya akan buat macam last week lah. Saya akan bagi soalan dekat dalam, mungkin dalam kita punya WhatsApp. So nanti you boleh terus jawab lah pada pukul, ke you all nak awal lagi soalan tu supaya you boleh, I mean for those ada masa nak jawab ke apa ke.
Awal.
Awal lah doktor.
Awal.
Okay, so saya bagi, kalau saya akan bagi awal. Okay, so and then you nak extend sampai pukul 12:30 malam ke sistem tu?
Ya, doktor.
Boleh doktor.
Okay, alright. So nanti saya akan bagi awal. I try to, tapi soalan tu semua saya akan pilih daripada buku Surabaya jugalah. Okay, so at least you, kalau nampak tak jelas ke apa semua, at least you can be dapat lah. Okay, so saya akan cuba bagi awal, dan juga waktu submission tu saya akan buka sehingga pukul 12:30 malam. Okay, so kalau itu yang kita agree, insyaAllah next week kita tak ada kuliah perjumpaan seperti sekarang. So kita akan buat exercise saja. Okay, so nanti bila the following week kita akan cuti seminggu, lepas tu kita akan buka, kita akan terus discuss pasal minggu ni lah. Okay, alright. So kalau tak ada apa-apa soalan, kita jumpa lah lagi nanti. Yeah. The question dia apa
It's assumed the data is infinite, doctor.
So yes, the infinite data. So I think the statement is infinite data, if I'm not mistaken.
Yeah, doctor. But
so
in table
yes.
there are.
Yes, because the question mentioned is infinite data. So infinite data, so you have to look the largest. So I think dia memang paling besar lah. Yang itu. Boleh ke? Anis Syafiqah kan tanya tadi? Oh, okay. So if you can find, okay, the table that I provide to you is just for the exercise. Okay. So if you can find for up to 1,000 data, by all means, please go on, use that. But during the test, the final exam, so you have to use the data, the table that I provide. But if dalam kerja yang sebenar, in your real calculation, in your real life, so if you can find other table that can represent for 1,000 data, by all means, dengan apa cara sekalipun, sila gunakan table tersebut. Okay, boleh It just, method tetap akan sama. Boleh faham? Alright. Okay.
Doktor.
Yes.
Saya pun ada nanya, doktor. Buku Indonesia ni ada sedikit beza, doktor, sama gambar Malaysia.
Okay.
The formula, so I just bit confused to pakai yang mana pun. Saya pun pakai yang Indonesia, doktor. Tapi yang di Surabaya tu pun beda formulanya. Beda sikit lah. In di Indonesia tu negative ln bracket ln times TR minus 1, doktor. But in Surabaya is minus bracket ln times ln TR darab TR min 1, doktor.
Okay. Alright. So in this case, Goris kan, bagi you Goris kan. Okay.
Yeah, doktor.
So basically what you can do is, it's good that you raise this issue. Basically it depends on buku mana you refer. So if you refer the Indonesian book, so please do follow the Indonesian guideline. Okay, for the purpose of design. But during the test, during the exam, please use the equation that I provide to you. So do you understand?
Understand, doctor.
But the method should be same. I mean the process should be
Yeah,
same.
the
Am I right?
process same.
Yeah. Okay. All right. So for the purpose of the class, so basically whatever method that I teach you, basically dia akan ada perbezaan dari segi equation. Of course, different state, different country have a different approach. Even kalau kita pergi kepada United States, they didn't use the Gumbel equation like we have now. The Gumbel distribution in the US, United States, what they use adalah they macam mana saya cakap, dia lebih detail lah. Maksudnya the way how they come out with what is the discharge for 100 years using Gumbel distribution function or Gumbel distribution method is different from whatever from the Malaysia, from the India and from the Indonesia. So, but the thing is, you have to calculate average, one thing. You have to calculate the standard deviation is one thing. Okay, so still it depends on what is the equation. Tapi mana-mana pergi pun, negara mana pun, you still need to determine what is the mean, the average and also standard deviation.
Yes, doctor.
Itu yang masih you perlu buat. Okay?
Okay, doctor.
Alright. So that since Goris mentioned about this and also Anis Afika mentioned about this, memang bila kita keluar nanti basically kita akan dapati banyak equation yang akan diguna pakai. Okay? But macam saya beritahu tadi, what we discuss in the first half of our lecture sebelum kita berehat pada pukul 7. Okay, so especially on the last part, which is the number 6, where we discuss about the upper limit, lower limit, how are you going to apply? So if you want to go, what is the maximum depth of the river that you want to excavate, or how wide, berapa lebar, how wide is the river should expand. So the process masih sama. Itu saja. So you still have the confidence limit, you still have the upper and lower limit. Pergi mana pun, pergi US pun sama, pergi India pun sama, Bangladesh pun sama. I think Indonesia also have the equation to come out what is the maximum range and what is the minimum range that you can go. So the process sama and the definition sama. Apa yang saya explain berkenaan dengan item nombor 6, yang last item yang saya reserve, yang paling lama saya discuss. Okay, so itu saja yang saya boleh bagi tahu. Okay, provided saya minta pelajar faham lah, itu yang that is the reason I keep asking you every single point that I discuss, I explain, I will ask you, do you faham ataupun tidak. But it is okay. So sekarang ni minggu kelima, kita ada lagi lebih kurang 9 minggu. So we can, you at the minggu 13 ke minggu ke-14, you still can ask me apa yang kita ajar, apa yang saya ajar pada minggu pertama, kedua. I don't have any problem. I can, insyaAllah, I try my best to explain to you lah. Okay? Alright, ada soalan? Okay, so kalau kalau tak ada soalan, jangan lupa verify attendance dekat dalam you all punya, dalam you future tu nanti. Okay, so mungkin ada yang tak ni saya buka yang masa pukul 10 malam. Okay, so kalau tak ada apa-apa, insyaAllah kita jumpa lagi lah pada selepas cuti semester break nanti. Okay, so terima kasih. Assalamualaikum dan salam sejahtera semua.
Waalaikumsalam.
Thank you,
Thank you,
Doctor.
doctor.
Terima kasih, Doktor.
Thank you, doctor.
Thank you, Doctor.